Thank you all for coming. I want to tell you all about the combination of serverless and GraphQL, where GraphQL is the thing that I work on a lot, and serverless is the topic of the meetup. And I actually think it's not a coincidence, because both of these are technologies I think that can help make developers a lot more productive, especially kind of product developers or front-end developers. So one thing that we've found is that in today's world, data management in your applications is more important than it's ever been. Back in the day, we used to build applications that were kind of server-side rendered, and the only thing you need to do was generate kind of the right HTML for every request that was sent to your server. But in today's world, your client is more often than not pretty long-lived. It might be a native app or a web app built with React, and you have to load up the data and manage it over a long period of time. And so now suddenly that data management component and that API that you're working with become really, really important. And actually, what we found and what we've heard from people, for example, Mark, who posted this post on Medium, is that people are spending up to half of their time, or maybe even more, as part of their UI development, actually doing that data management component, piping data through their React components, making sure that they get the caching just right. And it's becoming quite an important and sometimes frustrating part of your application development. And what I want to talk about today is how actually your API, not the front-end data management part, but the part that runs more on the back end on the other side of the internet, can actually be a very important component of making that front-end development experience a lot more convenient. So one thing that's getting really complicated recently is the amount of different platforms that we're expected to build for as developers. Not only are we having to build for a lot of different front ends, like iOS and Android and web are the three classic ones. There's a lot more now that are coming up. You might have a VR app. You might have to work with something like Google Assistant or some sort of microsite. There are also tons of different backends, because there are all these different technologies coming out on the back end, like with machine learning, different microservices they need to implement. Microservices themselves are now a trend. And so you often have to talk to multiple APIs, internal and external, as you're building your app. And with the combination of all these different front ends and back ends, it can get quite unwieldy. On the other hand, our front end tooling isn't really doing us a lot of favors. We've got all these advanced requirements for our apps. People are expecting something that looked like it was built with the budget of Facebook or Quora, or one of these apps that has hundreds of developers behind it. You want offline caching, error handling, optimistic UI for a fast response time. But the tools you get don't really afford that very well. You have to put together all this different stuff yourself into a system that does what you want. And so we think we found one option that can kind of take this to the next level and reduce the complexity of the system overall just very significantly. And it's GraphQL and Apollo. And we suggest that you can take GraphQL and some of the tools that we build and put them in between a ton of those backends and all those platforms that you're trying to build to really help organize how you're accessing that data for all those different front ends. And along the way, your front end code can become much simpler. All those things that we were talking about, all those different features that people expect from your application, because GraphQL is so well structured and it's a well specified API that you can use to describe all the data in your backend, all those things can be built into one particular tool. So for example, on the right of this code, here you see what it looks like to load some data with Apollo Client, which is our client-side library for retrieving GraphQL data from your server and putting it into your React components. And with just a few lines of code, you can declaratively do all this stuff like caching and error handling and loading handling and polling and any other kind of stuff that you might need to do in your app. And we've seen from people in the community, this is an example of Peggy, who's actually in our team now, but back when she was at MLS, she got excited about Apollo because it let her remove a whole bunch of complicated front-end code from their app that they were trying to build out with React Native. So how many of you have used GraphQL before? Raise your hand. That's about maybe half. So this is going to be a bit of a recap. But I think the way that GraphQL achieves these benefits is through three main kind of aspects. The first thing is you have a schema that describes all of the data that's available in your API. It has not only all the types of all the fields, but also relationships between them. The second aspect is that when you retrieve the data from the backend, you do it using GraphQL queries that don't specify stuff in terms of endpoints like a REST API might, but they do it in terms of fields and actually let you access multiple objects at the same time. So not only do you get all the data you want in one request, but you actually don't get more data than you were looking for because you specify exactly what you need. And then the third aspect is this thing I was talking about, which is a set of tools built around the specification of schemas and queries that let you be a lot more productive as a developer because they're built around this standard. And so people using GraphQL and using Apollo see a dramatic increase in their productivity. Okay, so what I really want to talk about here, that's all great positive benefits of GraphQL, but how do you really get there? How do you go from the world that most people are in today, where they maybe tried GraphQL in a side project or something new, into getting actually to use this in your job and being able to take your existing backends and your legacy code and your databases and actually be able to get all these benefits that I was talking about being able to dramatically reduce the amount of code you're writing and all of that good stuff. So what we suggest and what we've seen work really often is putting GraphQL actually as a gateway over your existing backend APIs. So what you see on the right is actually a diagram from a recent blog post published by Medium. I love Medium a lot, so this is close to my heart. And you can see what they did is they took this GraphQL server layer, and instead of rewriting the existing backends and servers that they had, they put it on top of the stuff that they already had implemented so that they could reuse all of their business logic, all of their permissions, all that stuff that you don't really want to mess with because who knows what it's doing. And they were able to get onto GraphQL, I think in their blog post they said just in a matter of months. And if you make that translation layer as thin as possible, you can actually keep doing things the way that you were doing. You can continue developing those services the same way, and then have that server, that GraphQL API, just be an easier way of accessing all of that data. And another tip here is we've seen GraphQL work the best when you treat it as a client-focused API. So you don't mess with your backend too much, like I said, but what you do is you think a lot about what is going to make this API as productive as possible for my front-end team. So you think about the UI that you're trying to build, think about the components that you're trying to implement, and think about how to get the data exactly in the shape that that front-end needs. And one really easy way to do that, and one that we've seen really succeed, is to actually execute a bit of a shift and put that API more under the control of those front-end developers that are actually requiring that data. So you might want to empower people who are building those UIs to add the fields that they need as they go. And that might inform the idea that you might want to implement your GraphQL API in JavaScript or some other language that's more accessible to those front-end types of developers. One of the things that I actually was just talking about with somebody earlier at the meetup today is one of the cool things about GraphQL is that because you actually request every field that you want specifically, it's not costly to add additional fields that you're not using because they're not going to increase your payload sizes like they would in some other kinds of APIs. But overall, because GraphQL is a great way to put this thin translation layer on top of your existing services, and because we've seen people be really successful when it's kind of has some ownership from the front-end developers, we realized that it means the GraphQL API needs to be actually very simple and quick to develop and deploy. And so that's what I want to talk about today. One of the things that we've been working on for a couple of months that is coming out very soon, but it's been in RC for weeks or also maybe months, is Apollo Server 2.0. So Apollo Server is our library for developing GraphQL APIs that in some way or another we've been working on for the last 2.5 years. And I'm really excited about Apollo Server 2.0 because it's designed for exactly the use cases that I've been talking about just now. It's got a dramatically simpler API to make it much easier for people to stand up that API layer. It's got production optimizations built in so you can feel really comfortable talking to those backend APIs that you're trying to access. And something that will come into play in a second is that it's got the same API no matter where you're running it. And you might imagine that at a serverless meetup, serverless platforms are one of those places. So one of the apps that we like to talk about is an app that Peggy came up with called Pupstagram, which is like an Instagram for puppy photos. But it's important. The important aspect of this is built over an API called dog.ceo. You can see it at dog.ceo that actually returns photos of dogs of various breeds. So they actually have a Twitter account. It's really great. OK, so somehow this text overlaps now. But the first thing you've got to do is define the schema of your GraphQL API that you're trying to develop. So for this app that we're trying to build, we're going to need to be able to retrieve some dogs. We're going to be able to retrieve images of dogs, and we want to get both a list view of all the dog breeds that we've got available and a detailed view of a specific dog. So we might want to write that down in our schema. GraphQL is this great schema language that's kind of language agnostic that lets you prototype that out really quickly. The next thing we want to do is think about what API we're going to retrieve that data from. And Apollo Server 2.0 has this new concept called a data source that actually does a lot of the optimizations that I was talking about for accessing those types of APIs for you. So what you do is you can specify the URL to your service that you're trying to connect to and implement a couple of methods that specify the endpoints where your data might live. And also perhaps you can see here a little bit of processing to maybe put the data into the shape that your gateway expects. Then you take those data sources that you implemented and the schema that you designed, and you wire them together using resolver functions. And you basically just implement a resolver function for every field in your API that needs a data source to talk to. And it's quite simple. It's just a little bit of a glue layer. And then you're basically done. You call the Apollo Server constructor, you put all that stuff in there, and you've got a production-ready GraphQL API. And that's what it's all about, something that used to require a whole bunch of different tools that you had to think about very carefully. Now we hope to use this new technology to empower a whole new generation of product developers to stand up that GraphQL API that's going to make them a lot more productive, much more easily, and without having to think about all the details they used to have to think about. So we're gonna do some demos here, and this one is not going to be very complicated because hopefully it's already running. So here we've got this app that's loading from our REST API, and there it goes. Cool, it worked. It's a little bit zoomed out. Not very good at CSS. But we can also, another thing we can try doing is actually accessing our GraphQL API and running some queries against it. So here I've got, GraphQL Playground, which is a tool you can use to easily test out GraphQL queries. And this is one of the best parts of GraphQL is that you can really easily explore what data an API has inside of it just using this nice auto-completing interface. So for example, we can do the thing that we were looking for. We can get a list of dogs. We can look at the different breeds that they have and run that query, and okay, we've got a list of breeds. So that's pretty cool. And just to confirm, the code that I'm showing you does indeed look like the code that I had on the slides. This is where we've got our data source. This is where we've got those resolvers. At the top, we've got the schema. So there's no special code here that I'm not trying to show you. Okay, great. So we've got our server running locally. That's all well and good. We've got our prototype. We're able to look at the app. Very cool. So now what do we do with it? I mean, it's pretty straightforward to get an app running on your computer, but this is where I usually chicken out. I've got my side project running on my laptop, and then I'm like, do I really want to maintain this thing? Because it's probably going to go down. I'm probably going to forget the credit card subscription to the thing and the other thing. So if we want to think of our GraphQL layer and our app as this thin thing over our existing APIs, if we want it to actually make us more productive and not less productive and have to worry about even more stuff, we want the simplest possible way to deploy it. And that's where I think the whole serverless thing can really come in handy. I think serverless is a great fit for GraphQL APIs because it can take this thing that might feel like you're standing up an extra server and turn it into not a server because it's serverless. So it's something that manages itself. You don't have to worry about scaling it up and down. It's a relatively small amount of code compared to all these things. And thankfully, Apollo Server, this library that we were just talking about, it does run with Node. You can run it with containers, Heroku, anywhere you want. But it also runs in exactly the same way on all of these serverless providers. So the same way that you can implement a real GraphQL server, you can implement a serverless GraphQL server as well. And that's represented by a cloud in this diagram. So one thing that I've been playing around with recently that I think has been really, really cool is something that really touches this, this sense of making server development really, really easy for those product developers or those front-end developers, which is the new release of Netlify functions, if you guys have heard of those. Surprisingly, I feel like they haven't made as much noise about them as I think they should be. But essentially, what it does is you can actually take your UI code that you used to deploy to Netlify. Who here has used Netlify, by the way, in the past? Oh, okay. So Netlify is it used to be mostly a static site deployment platform. So you get your static site generator. If it's like Hugo or Gatsby, you deploy a bunch of files onto there, and it's kind of like a CDN that hosts your files. But the big new thing that they released is that you can now also put some JavaScript code next to your other JavaScript code, but instead of being deployed to the front end, it actually puts it into Lambda for you. So you've got this repository that's got a serverless function in it, and it's got your UI. You put that on GitHub, you set up the integration with Netlify, and your application is deployed. And so I want to show you a little bit of what that looks like, because I strongly identify as a front-end developer, and for me this was just a breath of fresh air where I finally felt like somebody was really speaking to me and not to somebody that wants to click on a bunch of AWS dashboard buttons, which there's always too many of them. And so here's my repository. You can see that I've got a repository here with just an API folder that's got this GraphQL code that I was talking about. And right next to that, it's got this UI code that's in React. And it's pretty simple. You just connect Netlify to GitHub, and it's got your list of deploys. And all you have to do is push to GitHub, and it takes about 30 seconds to deploy both the Lambda and the front end, which is pretty insane. And I didn't even have to go to AWS, and I didn't have to run any CLI tools of any kind. And this is already the tool that I use to deploy all of my static sites anyway. So I thought that was pretty sweet. And to show you that it's running on the internet, I can put in that URL, and I'll go to this .netlify.com site, and you'll see the same app running up there. Boom. And then the other thing I can show you is, again, with this GraphQL playground, we can now connect just to prove that the endpoint is on the internet as well. You can put in that URL, and it's cool because it actually uses the same domain name and kind of proxies this URL here to Lambda. We can actually run that same query that we ran. I guess it hasn't changed, so I can put some more stuff in here. Let's see. We can get a list of subbreeds, apparently. So there, we can actually run this query, and some of these do have subbreeds. So now we've got that same API that I had running locally on my computer deploy to the internet. And later there will be a demo where I actually try to redeploy, so we'll see what happens. Great. Okay, so that was super simple. We literally just put some code in GitHub. We got React. We've got a Lambda. It literally could not be easier. It's incredible. So this is one of the things that really spoke to me in terms of reducing friction in not just developing, but deploying APIs. Because this is the type of workflow that I'm already used to using for my static sites. Got 20, 30 sites on Netlify, but now I can use the exact same workflow for deploying my backend code. The other thing that's incredibly awesome is that Netlify is famously known for having a deploy previews feature, where when you open a pull request on GitHub, you actually get a version of your site with a prefixed URL that is the code from that pull request. And it does the same thing for your Lambda code. So when you open a PR, it deploys a staging version of that Lambda for you for every single pull request, so you can test out if your code is working. And we'll see that in a second. So what about other stuff? What about the things that you need to kind of run a production endpoint that you usually need to think about if you're kind of like a backend developer running an API? Well, it actually gets even more interesting with GraphQL, because with GraphQL, there's actually only one endpoint. There's just that URL that I put in that says /GraphQL at the end. And so what we really want to see is we want to see our performance data in terms of that API that we implemented, in terms of those fields and the queries and all that good stuff. So what do we do about that? Well, leading question. So we've also got a tool for that. So in addition to Apollo Server, which is the library that you use at runtime to actually implement that API, we've got a service called Apollo Engine that we think provides a whole set of tooling that you're going to want when you're managing this kind of lightweight API layer. So not only can you monitor your GraphQL resolvers to get the performance data of each individual field separately, you can also track schema changes over time, integrate into all your favorite tools like Slack and GitHub and all that stuff. And I'll show you how that works in a second. So for example, one thing you can do is browse the current version of your schema. So anybody in your company can go and look at what your current schema looks like, look at when it was deployed, look at, this is a very simple demo app, so it only has 3 types, but it'd be more interesting in production. And it really gives you a central place to understand what the heck is going on with that API layer. So it's not this weird black box that somebody deployed over the weekend once. And another thing is, like I said, you can get that per field performance tracing. So, you may have noticed that that API is a little bit slow. I promise it's not our fault. We really wanted to get those dog photos, and unfortunately that API isn't the fastest thing around. So some of those dog photos take up to 3.5 seconds to fetch, and we can actually determine that with this tracing feature that you've got in Engine, and I'll talk about how to improve that a little bit later. All right, so what does it look like to actually open a PR with a change? So thankfully, I've already opened a PR, so you don't have to see me type a bunch of code and then push that to GitHub. And we'll find that on GitHub. All right, perfect. So you will see that here on the thing that I just pushed, you can see the deploy preview. And what I've done is I've actually added a field to the API that populates a new title. So, actually maybe we can look at this diff. So I've added a field to my GraphQL API called title. I've added a function that returns a string called hello serverless. And then I've added some code to the actual React component to display that field. And so I've made a change both to the API and to the front end. And then in the app, you can see this hello serverless text show up. And you can see in the URL that this is a deploy preview. This isn't our production app. And so this is one of those that we would get for every single pull request. And then another cool thing we get from Engine is we get this schema diff, where we can click on that, and we can actually see what changed. And it says, we noticed that you added a field to your API, and so now in our dashboard, we'll be able to see those changes. All right. So one thing that comes up really frequently is, what about caching? We saw that that API was pretty slow. You might want to make it fast. That'd be pretty cool. So what we found is the best option is actually not to cache the GraphQL results, but actually cache those underlying REST calls, because those are repeated very frequently. And that's where those data sources come in. It's a modular pattern for accessing your REST APIs for GraphQL. It makes it easier to build those proxies. It's got a bunch of production features built in, but one of the most exciting ones I want to tell you about is that you can actually just really easily wire it up to a Redis cache. And so this data source code, you just pass it in an environment variable that has a URL to your Redis. Maybe it's a cloud hosting provider if you want to be really serverless about it. And then you get caching out of the box for free. And so now your diagram looks a little bit like this. You've got a couple of different services running, but at the end of the day, your code is still quite simple, and it's still very easy to deploy. So zooming out, basically there's a couple of different tools involved here, but they're all tools that you don't really have to think about, you don't have to manage, because at the end of the day, all you really do is push some code into a GitHub repository. And these are all tools that people have put together to be a really front-end and product developer-focused way to do API development and front-end application development. So, I think the key premise here is that the best way, I think, to improve your API, the best way to improve your development velocity might actually be to improve your API and your data management, not necessarily continue to look into more front-end focused tools. So I hope that you give GraphQL a shot and you give Apollo a shot. So I'm kind of running out of time here, so I'm going to run through the rest of this stuff really quickly. But generally, we're trying to go for an ideal developer experience. So I want to show you two really quick things that we think are going to take it to the next level. One is that you can run JavaScript anywhere, and it turns out you can also run JavaScript inside CDNs now. And so one of the things we're working on is actually the ability to run Apollo Server inside Cloudflare, so you can deploy it to 151 data centers at the same time. If you want to learn more about that, go to apollographql.com/edge. And the other thing is tooling directly in your editor. And these are some really cool GIFs. So I might go a minute or two over, but they're so cool. So basically, now that you've got this fancy schema and you're writing these queries, how do you make your editor aware of it so you can be really productive? And so we're working on a Visual Studio Code extension. The most basic thing it's going to do is allow you to write queries with auto-completion, but it also allows you to run those queries directly in your editor. So right as you're prototyping your UI code, you can see what data it's going to return, which I think is really awesome. Another thing you'll be able to do is even retrieve real-time data from your API. So this is an example of a GraphQL subscription, and it actually will open a WebSocket to your server and receive real-time updates. As you can see, it's a little small, but the timestamp is changing here. So you'll be able to do real-time GraphQL subscriptions as well. And remember I showed you that performance data from Engine that keeps track of how fast your API fields are going? You'll be able to know how fast your API fields are directly from your editor before you even run those queries. So it'll annotate those fields that you're writing with P50 or P99 performance data. And then overall, I think this will just add up to a really productive API experience that you've never been able to have before you had GraphQL, before you had that schema, and before you had these queries. So I'm really excited about that. Hopefully it's going to come out soon. I had to give this demo without it, which was really sad, but just hold on. Anyway, and that's the end of my presentation. I'm really excited to keep working on making using and developing APIs fun and productive. And I'm really excited about how serverless and making it really easy to deploy is going to be part of that too. Thank you. I think that at the very least, that will be the reality for a whole lot of people for the next several years, because while GraphQL has a whole boatload of benefits for those product and front-end developers, I think the benefits to the backend and microservice development haven't been as well understood yet. So while I do hope that eventually more and more APIs move into GraphQL, that's not as big of a priority for me. And so our biggest priority right now is very much empowering those product developers to get productive as soon as they can. And if later, more and more APIs like microservices also start to go to GraphQL, I think that would be icing on the cake, but just not the current priority. And if we need to come up with caching that works better with that situation, then we'll also have to do that. I think there are a lot of trade-offs there. So my talk is primarily about API gateways, so something that lives closer to the front end and kind of might aggregate microservices together. Microservices, I think, at times can work with things that are a lot more stateful, like message queues or persistent connections to different systems. So I think it might be dependent on the service whether or not you want to have that be a kind of serverless, stateless type of situation. For the API gateway, I'm a lot more confident that you want that to be stateful because it's a part of your architecture that at least, we've heard that people don't want to worry about it. They want it to just work and they don't want it to crash ever. So I'm very confident that API gateways are a good fit for that model. Then with GraphQL specifically, even though there's only one endpoint, I think you still get a lot of the benefits of very easy deployment. One of the things I showed off was the ability to very easily stand up like a staging API for a pull request on GitHub. I think that would be a lot harder if you had to actually create a new container and run it with persistent CPU and memory for every single pull request. So I think in general, serverless architecture enables a better developer experience, even for things that are more monolithic in some sense, because you might want to stand up a lot of different instances of that thing. I think what I've seen the most frequently is people relying more on external services. There are services that will host WebSockets or message queues for you kind of outside of your code. And I think the overall goal a lot of people have with this type of architecture is just reducing kind of their maintenance burden. And so if that external service helps you do that, then it might fit well into that architecture. I think the best way to learn about Apollo and GraphQL is to go to our docs. If you go to apollographql.com/docs. Also, if you Google around, there's just hundreds and hundreds and hundreds of kind of tutorials and blog posts and different kind of example apps. But we've just recently overhauled some of our documentation to be a lot more step-by-step story-based. So for example, you can learn about how to build a server with Apollo Server 2.0 in just a couple of steps, how to deploy it, all that kind of stuff. Okay, so Apollo Engine is primarily a cloud service that that we host that aggregates the data to be able to display you this information about your API. And in the past, it had a component that also ran inside your code. But we've actually recently migrated and open sourced all of that and put it into Apollo Server. So now there's only two components. There's the open source component that runs inside your app, and then there's the cloud service, which is Engine. And it's Apollo Server itself that now does all the stats collection and all that stuff, and that runs just fine inside the Lambda. So we actually had to build a lot of new infrastructure to be able to better aggregate stuff because people were sending a lot more reports because they were sending kind of one report per function call. So we did a little bit of work, but serverless was so important to us to support that that's kind of how we got here. So there is a free tier. Engine is totally free for that schema versioning stuff that I was showing. So you can easily set it up with GitHub and see those diffs of how your schema is changing, all that stuff. Do that auto completion in your editor. And then for the actual performance monitoring aspect, it's free up to 1 million queries per month. Thank you.